Good morning, madam. This is Akelo Frida Juliet, and I'm redoing the video summaries for organic chemistry. And I would like to start by defining what organic chemistry is. And this is a branch of chemistry that deals with the study of compounds containing carbon, excluding those ones containing carbides, carbonates, and simple oxides. Then I have properties of carbon that makes it have to form very many compounds. We have one as being the tetravalency of carbon, where it is able to form four strong covalent bonds which can bond with other carbon atoms or other elements to form a variety of compounds. Another one is a hybridization of carbon, where carbon is able to undergo sp cubed, sp squared, and sp hybridization due to the formation of very many geometries, and that's forming also very many compounds. Then you have one that is a catenation property of carbon, where carbon is able to form long chains and branch chained compounds. Then you have the strong covalent bonds in carbon, which can combine with other atoms to form a variety of compounds. And carbon also has a small atomic size that enables it to form compact structures which are strong. Then I have a classification of organic compounds. Organic compounds are classified as hydrocarbons, saturated and unsaturated. So hydrocarbons, these are organic compounds containing carbon and hydrogen in their structure. The examples can be alkanes, alkenes, alkynes. Then saturated hydrocarbons, these are basically the ones that have single bonds. And then the unsaturated hydrocarbons are those that have double or triple bonds. There is something else about this, and that is homologous series. And this is a family of organic compounds that have the same functional groups and the general formula. Homologous series have properties. Okay, compounds in grouped in homologous series have properties like they have a gradual change in their physical properties. Their chemical properties are similar, and each member is different from the other by a CH2 unit. So I think I can now go and talk about alkanes. And alkanes are saturated hydrocarbons with single bonds in their structure. They have one strong covalent stigma bonds. Then they undergo sp cubed hybridization, which makes them to assume a trigonal planar shape. They have a general formula of CnH2n plus 2, but then they are less dense than water. Then they are insoluble in water because alkanes are nonpolar while water is polar. So but they dissolve best in nonpolar solvents like benzene. Examples of alkanes, we have methane, ethane, propane. Then boiling points. Branch alkanes usually have a lower boiling point compared to their sweet chained counterparts, because branching decreases the surface area of contact of molecules, thereby decreasing the intermolecular forces holding those molecules, thereby requiring less energy, thus reducing on their boiling points. Alkanes can also have some uses where they can be used as fuels for cooking and heating activities. They can also be used as lubricants in machinery to prevent friction and wear. They can also be used as solvents. The next one is alkanes, and alkanes are unsaturated hydrocarbons containing one or more single double bonds in their structure. they have a general formula of CnH2n. They undergo sp square hybridization. Examples of alkenes can be ethene, propene, pentene. So alkenes, just as alkenes are insoluble in water due to their non-polar nature, then they are also less dense than water. Then alkenes can have uses like they're used for making synthetic rubber. They are also used for making polymers. And next thing I'm going to talk about is alkynes. And alkynes are unsaturated hydrocarbons with triple bonds in their structure. Okay, sorry, alkenes first of all, they have one strong stigma bond and the other one weak pi bonds. So the pi bonds, the weak pi bonds are the ones responsible for the reactivity of alkenes. So let's move to alkynes. And alkynes are unsaturated hydrocarbons with triple bonds in their structure. They have a general formula of CnH2n minus 2. Then they undergo sp hybridization. They are composed of two weak pi bonds and one strong stinger bonds. So the two weak pi bonds, they are responsible for the high electron density in alkynes, making them to be more reactive than the alkenes. Alkenes, they are also, just like alkenes and alkynes, are insoluble in water. They are also, due to their polar nature, then they have a lower density than water. Then examples of alkynes can be methane, propane, butane, like that. Then I can go and talk about now alcohols. And alcohols, they're organic compounds, and they have a formula of R hydroxyl. Alcohols have a functional group of the hydroxyl, that's hydroxyl group, and they're classified into three, that is the primary, secondary, and tertiary alcohols. So the primary alcohols have their hydroxyl group attached to a carbon atom, which is attached to one other carbon atom. Example of primary alcohols can be methanol, propanol, like that. Secondary alcohols, these ones have the hydroxyl group attached to a carbon atom, which is attached to two other carbon atoms. Then the tertiary alcohols, it has its hydroxyl group attached to a carbon atom that is attached to three other carbon atoms. Then the hydroxyl group increases the boiling point of alcohols because hydrogen bonding in alcohols is responsible for the high boiling points in alcohols because hydrogen bonds are too strong and they may require sufficient energy to break them, thereby increasing the boiling point. Then next one is ethers. And ethers, they have a formula of ROR with the oxygen acting as a linkage between the two carbon atoms. Ethers are volatile liquids known for their distinct odors which are not pungent. Ethers have a lower boiling point compared to alcohols because they lack hydrogen bonding, but they have a higher boiling point compared to alkanes because of their polar nature. Then they are used as solvents because they can dissolve a wide variety of organic compounds without taking part in the chemical reaction. Then since they are volatile and if they are exposed to heat, they can form explosive peroxides. So proper storage techniques should be taken place when handling ethers by storing them away from heat sources and ensuring proper ventilation to prevent inhalation hazards. Let me talk about alkali halides. And alkali halides are classified into three, where we have the tertiary, the secondary, we have the primary, secondary, and tertiary halides. So the primary halides, this one have the halogen group attached to the carbon atom, which is also attached to one other carbon atom. Then the secondary halides, these ones have their halogen group attached to a carbon atom that is attached to two other carbon atoms. Then finally, tertiary halides has their halogen atom attached to a carbon atom that is attached to two to three other carbon atoms. Then we can talk briefly about carbonyl compounds, and carbonyl compounds this include aldehydes and ketones. Then generally aldehydes are more reactive than ketones due to lack of the steric factor. Aldehydes, they have that prefix of al, where the examples can be propanol, ethanol, methanol, and ketones have the prefix of on, where the examples can be butanone, propanone, like that. Then we go to carboxylic acids, and carboxylic acids are weak acids since they have a proton donor in their structure. Then they have a formula of RCOO, and they have a carbonyl functional group. They are soluble in water due to the hydroxyl group. Then they are polar due to the electronegativity difference between the carbon and the oxygen atoms. Naming of carboxylic acid follows the prefix of oic, where we have examples like methanoic acid, ethanoic acid, propanoic acid. So they can be used as preservatives. They can be used for making pharmaceuticals in industries. They can be used as flavor enhancers, and they can be used as beverage additives. Then let me talk briefly about amines. And amines are organic compounds derived from ammonia by replacing one or more hydrogen atoms with an alkali groups. Then amines, they are classified into three. There I have the primary amines, secondary amines, and tertiary amines. Primary amines, these ones have one hydrogen atom. This one, their hydrogen atom, the hydrogen atom in amines is replaced by one alkali group. Then for the secondary alkali halides, two hydrogen atoms in ammonia are replaced by an alkali group. Then for tertiary amine, they have all their three hydrogen atoms being replaced by all their three functional groups are being replaced by the alkali group. They undergo 3-cubed hybridization just like alkanes. And then amines are weak bases due to the lone pairs of electrons on the nitrogen atom, which can accept protons from acids forming ammonium ions. Then uses of amines amines can be used in color synthesis and in making of fertilizers. So let me talk briefly about aromatic compounds. Then these are okay. To begin with, definition: aromatic compounds are hydrocarbons containing one or more benzene rings. So classification: amines basically are classified into three. That is the monocyclic aromatics. Aromatic compounds are classified into three. That is monocyclic aromatics, polycyclic aromatics, and functional aromatic derivatives. Aromatic compounds, they undergo 3p² hybridization. Then benzene. Okay, and now the properties of benzene. Benzene has a lower density than water. Then it is partially soluble in water. Then also describe it. It is a clear, transparent liquid. Then also there is a way sometimes compounds are arranged in the benzene, whereby we have the ortho, the meta, and the para. In ortho, the compounds take up positions 1 and 2. In meta, the compounds tend to take positions 1 and 3. Then in para, compounds take up positions 1 and 4. I think, madam, that's all. Sorry. Then in the other part of organic reactions in organic chemistry, we have reactions like addition, substitution, halogenation reactions. We have also we have addition, substitution, halogenation, alkylation reactions. I think that's all the brief summary I had about organic chemistry. Thank you so much, madam, for listening.